All right, let's dive into a topic that honestly quietly sinks countless AI projects. We're talking about the economic architecture of sustainable AI. This is the stuff nobody talks about until it's too late, and it's why so many brilliant ideas just fizzle out. So let me ask you something, especially if you're leading one of these projects. You've got the team, you've got the cool tech, you've got the data, but what if I told you your AI initiative might just be a ticking time bomb waiting to go off the second you actually get it right? Because here's the brutal truth we're seeing play out everywhere. A ton of amazing AI projects are failing. And the reason? It's not the algorithm, it's not the data, it's the economics. There's a silent, fatal flaw baked right into their financial design. And that brings us right to our first section here, AI's hidden cost crisis. We're going to pull back the curtain on what this really looks like. And you know why it catches so many smart people completely by surprise. You know, the root of this whole problem is this really dangerous assumption. Leaders get so excited about what the AI can do, its capabilities, that they just figure the cost, the affordability that will just sort itself out down the road. But it almost never does. And this chart, wow, this just nails it. It's called the AI bill shock. Look, the pilot starts and the costs are tiny, looks great, so you project out your costs and it still seems pretty reasonable. But then you succeed, people love it, usage goes through the roof, and that actual bill shows up. And it is a massive shock to the system, one that can absolutely kill a project. So why? How does this happen over and over again? Well, that leads us right here, the inference trap unveiled. To avoid the trap, you first have to understand the engine that's actually driving all these costs. The magic word is inference. Now let's forget all the technical jargon. Just think of it like this. Inference is the moment the AI actually does its job. It takes a request, thinks for a second, and gives you a response. Every single time that happens, the meter is running, it's the heartbeat of your AI, and it's where all the money is spent. And this is where the old playbook gets thrown out the window. In the old world of IT, you controlled cost by hammering out a good deal with your vendors. But with AI, that's not it. It's an architectural problem from day one. See, demand is elastic. The more useful it is, the more it gets used. And a tiny little choice you made months ago can simply have massive, and I mean massive, financial consequences. Okay, but it is not all doom and gloom, I promise. There is a way to get a handle on this, and it comes down to what the source material here calls the overlooked strategic lever. This is the piece of the puzzle that almost everyone misses, and here it is, this is it. The single most important design choice you're going to make, and it's the one that nobody ever talks about in those big strategy meetings. Where does the inference happen? Not what model you're using, but where is it physically or virtually doing the work? And why is that one question so critical? Well, because the answer determines pretty much everything that matters. It dictates your cost per query. It affects how fast and reliable your service is. It can even expose you to foreign currency swings. And here's the big one. It determines whether you can actually scale this thing without going bankrupt. Which brings us to the hero of our story today. This is the strategic move that gives you back control. We're talking about local inference. It's your counterbalance to all that cost and chaos. Now, let's be really clear about something. This is not about saying no to those huge, powerful global AI platforms. Not at all. It's about being smarter. It's about giving yourself options. Introducing architectural choice so you can always use the right tool for the job. And here's what that looks like in the real world. You start to differentiate your workloads. For those really high stakes, bet the company decisions, of course, use that premium expensive global model. But for all the routine stuff like summarizing an internal meeting or sorting emails, a much cheaper local or open source model can do that job perfectly fine for just a tiny fraction of the cost. So the whole game changes, right? The goal isn't to be locked into a single AI provider anymore. The goal is to manage a portfolio of models. And when you do that, you're not just saving money. You're building real, actual economic resilience into your whole AI strategy. Okay, so how do we actually do this? How do we put it into practice? That brings us to our final and most important section, building economically sustainable AI. And spoiler alert, this is a job for leadership, and this is maybe the single biggest takeaway today. Affordability is not some task you can just hand off to your engineers and hope they figure it out. Designing a system that can actually survive in the real world economically is a strategic leadership mandate. It has to start at the top. So what do? You start by asking some tough questions. The first one you should walk into a room and ask your team tomorrow is this: which of our workloads truly need our most expensive top-of-the-line model? Make people justify it. Question number 2 is all about the future. Forget next quarter. Ask your team this: what happens if we hit a home run? How will our costs scale if our usage suddenly grows by 10 times? And if they can't answer that with confidence, you've got a problem. And finally, this is the most important one. What architectural choices have we made right now to make sure our costs only go up when we are delivering real proportional business value? Your AI bill should feel like a celebration of success, not a punishment for it. The source material really wraps this up with a powerful and kind of sobering quote. Think about it. Systems that are economically unsustainable eventually stop being strategic priorities. AI will be no different. History is littered with brilliant technologies that were just too expensive to run. So I'll leave you with this one last question to chew on. As you look at your own projects, are you building them just for their capability, for what they can do in a demo? Or are you building them for survival, for what they can sustain in the real world? Thanks for joining us for this explainer video. See you next time.